Okay, I'm going to try to do the Chapter 4 review. You should absolutely, before you watch this video, have tried to do the review by yourself, checked your answers, and as you're watching the video, if you need to watch me do every problem, that's fine. But honestly, this should be not a video that you watch every second of. You should just fast forward to the problems that you didn't get correct, focus on those, and the problems that you got correct, you don't need to watch me solve again. So my idea behind the reviews, so the reviews are supposed to be a practice test. Take the review like it's a test, then watch the bits of the videos that you need to watch, but you shouldn't have to watch the entire video. That's definitely not the design of my reviews. So let me see what I can do here. I normally go a little bit faster on my reviews than my regular lectures. Don't maybe include exactly the same amount of detail as a regular lecture, so that should be the case here. Also, this morning my deodorant ran out after one side, so I've got more desire to get out of here quicker. Fortunately, I'm here by myself and nobody's having to suffer with me, so I might go a little bit fast. Part A of number 1 wants me to take the right side of the g function, set it equal to 0. Take me 2 steps to solve. There's no square, so I don't need to worry about factoring. I'm going to minus 4 from both sides and divide by negative 5. When I minus 4, I get minus 5x equals negative 4, and then I'll divide by negative 5. On the left side, the negative 5's cancel. I'm left with my x. On my right side, I have 2 negatives that are going to cancel to be a positive. And I get x equal to 4/5. B is similar, but it's a little bit harder because of the greater than. But I'm going to take the right side of the g function and work with it. I'm going to set it greater than 0. I'm going to do essentially the same bit of algebra. I'm going to minus 4 and divide by negative 5. The difference working with a greater sign than with an equal sign is that I have to be careful to switch the sign if it needs to be switched. Minusing 4 from both sides doesn't cause me to switch the direction of the sign, but dividing both sides by a negative number, that is a time where I need to switch the direction of the inequality. And when I go to write my answer to this, when I do this division, the negative 5's cancel. I'm left with the x. Because I had to divide by a negative, I need to switch the greater than to a less than sign. And on the right-hand side, I still get the same 4/5. So x is less than 4/5 is the perfect answer for part B. I don't have to write set builder or interval notation. This is a completely adequate answer. For part C, it asks me to set the right-hand side of the f function equal to the right-hand side of the g function. So I'm going to set the 3x minus 12, which is the right side of the f function, equal to negative 5x plus 4, which is the right side of the g function. I'm going to add 5x and add 12 to both sides. When I do that, I'm going to get 8x equal to 16. To finish the problem off by dividing both sides by 8. And that will give me x equal to 2, which is going to be my answer. D wants me to take the right side of the g function, negative 5x plus 4, put a less than sign, and then put the right side of the f function, which is 3x minus 12. Again, I'm going to solve this for x. I don't have to factor because there's not a square. Just need to get the letters on one side, the numbers on the other. I minused 3x and minus 4 from both sides. If I minus 3x from the left side, both the x's have negatives in front. I'm going to add them and keep them negative. 4's will cancel. On the right-hand side, the 3x's will cancel. The 12 and the 4 have the same sign, so I add them and keep them negative. So minusing 3x and minusing 4 gives me negative 8x is less than negative 16. I have to again divide by a negative, and if I divide by a negative when I'm solving an inequality, that's when I switch the direction of the inequality. And I can write my answer, and I'd like to write it in a box so you can see it. On the left-hand side, the negative 8s will cancel, leave me with the x. Divide it by a negative, so I need to switch the less than to a greater than. And negative 16 divided by negative 8 is positive 2. So x is greater than 2 would be a perfect answer for part 1D. 2 has two parts to it. The first part is to come up with an equation to fit the data. The second part is to answer a question using that equation. The words are essentially the same as a word problem we did earlier in the chapter, and I just changed the numbers. That's real common when I make word problems up for reviews and word problems for tests, is that I use the same words, different numbers. In this problem, the 100 televisions that the district purchased is irrelevant in terms of solving the problem. What I need to do is come up with an equation of a line that maps the data, and to do this I'm going to come up with 2 points, and my points are going to be in the form the time or the age of the television and their value. I know that after 8 years the TVs are going to be worth $2,000. And I know their initial value is $50,000, and for that time that's a zero years old. So the points I needed here are 8 and 2,000, 0 and 50,000. I'm going to find an equation of a line by first finding the m. I'm going to go y2 of 50,000 minus y1 of 2,000 over x2 of 0 minus x1 of 8. This is going to give me 48,000 over negative 8. The slope is going to be negative 6,000. Once I find an m, I need to find a b. I'm going to use the equation y equals mx plus b. I'm going to use m equal to negative 6,000. I could use either point, but the second point, because of the 0, is going to be a lot easier to use. I'm going to use x equal to 0, y equal to 50,000. Plug those into that formula and get 50,000 equals negative 6,000 times 0, that's times 0, plus b. This 6,000 times 0 is 0. So this is going to give me 50,000 equals 0 plus b. So that's going to give me b equal to 50,000. Now I'm ready to come up with an equation of a line, and it would be adequate if you wrote y equals negative 6,000 x plus 50,000 to name your equation. It is a function. It's not written in function notation. The way the problem is written, the question is written, looks like I want to have function notation in my answer, so I might want to do that. And I don't know, maybe that's all I'll do here. I'll go in or, and I might do this, v for value of x. I could do v of t, value over time, equals to, in fact, let me do that, v of t, that's a t, equals negative 6,000 t plus 50,000. This might be a much nicer name. It shows that the value relates to time rather than the y and the x. Using letters that are maybe relevant might make it easier when you go to answer the question that's posed, but either of those would give you first full credit. Find the value after 6 years. I just need to plug in 6 for x if I'm using the top equation, 6 for t if I'm using the bottom equation, because 6 stands for the number of years. In the top equation, my x stands for the number of years. In my bottom equation, the t stands for the number of years. And if I did the math there, negative 6,000 times 6 is negative 36,000. And if I do that math, negative 36,000 plus 50,000, I get $14,000. So the value after 6 years is going to be $14,000. And that would be completely adequate for part 2, question 2, part B of question 2. Okay, 3 gives me some information about a real estate office that manages 1,000 apartment units. Again, exactly the same words that we got in a word problem earlier in the chapter, just new numbers. The first 1,000, although it's important, it's not the deal, the thing that's going to help me do or not do the problem. What I need to do, part A says come up with an equation, and it's going to be a line. In order to get the equation for the line, I need 2 points, and I'm going to do my points like this. I'm going to do the x coordinate as the price, the y coordinate as the number of units rented. Demand means number of units, and it says make y be the demand here being the number of units. For the x coordinate, I'm going to put the price. The first point, I'm going to use $1,000, 1,000 units, and that's going to make the point 1,000, comma 1,000. The second, I'm going to use $1,300 and 900 units. So price first, number of units second. I'm going to come up with an equation of a line that fits this. First, I'm going to find the m. I'm going to go m equals to y2 of 900 minus y1 of 1,000 over x2 of 1,300 minus x1 of 1,000. This is going to give me negative 100 over 300, which reduces to negative 1/3. Now I'm going to find the b. I'm going to use the equation y equals mx plus b. I'm going to use the m that I just came up with of negative 1/3. And it doesn't matter which point I pick. I like the top one because I can hardly go wrong. I'm going to go x equal to 1,000. And y equal to 1,000. So even if I messed up, I couldn't go wrong. So I'm going to go 1,000 for y equals m of negative 1/3 times 1,000 for x plus b. Eventually, I'm going to probably have to round here. Let me do this multiplication. This is going to give me in fact, let me do the multiplication. This gives me 1,000 equals negative 1,000 over 3 plus b. Don't like the fractions. I'm going to multiply 3 by 3 to get rid of the fraction. I'm going to multiply this by 3, this by 3, and that by 3. Multiplying 3 times 1,000, I get 3,000. Here, the 3's are going to cancel. I'm going to get a negative 1,000, and here I'm going to get 3b. Now I'm going to add 1,000 to both sides and get 4,000 equals to 3b. Divide both sides by 3 and get 4,000 over 3 equals b. So the equation I'm going to come up with, I could write for my answer y equals to negative 1/3 x plus 4,000 over 3. That would be completely fine. I notice in my wording I don't say write function, so that probably means I don't need the function notation. But it does say use p for price. I'm using x for price in this instance. It might be better if for an answer I change that x to a p and write y equals negative 1/3 p plus 4,000 over 3. That would probably be a better final equation. That's the equation that gives the number of units demanded in terms of the price. So that's part A. Part B wants me to use the equation. Part B says predict the demand at a price of $1,200. So again, that equation is y equals negative 1/3 times p plus 4,000 over 3. For part B, I'm going to use the equation. I'm going to plug 1,200 in for p because the 1,200 is a price, the p is a price. I'm going to go negative 1/3 times 1,200 plus 4,000 over 3. And I certainly need to round this. I'm going to do this all on my calculator. So I'm going to go clear negative 1 divided by 3 in parentheses for safety, even though they might not absolutely be necessary, times 1,200 plus 4,000 divided by 3, I get 933.33. So the equation actually says there'll be 933.33 units demanded. I'm going to round to 933 units for the demand. So I'm going to say the demand is 933 units, and I have to round, and seemed like a sane way to round. Part C says at what price would 800 units be occupied? That means I need to plug 800 in for the y and solve for the p. So I'm going to go 800 equals to negative 1/3 p plus 4,000 over 3. I'm giving myself lots of space because I want to clear the fractions. I'm going to multiply by 3. As a matter of fact, I'm going to multiply by negative 3 to get the number in front of the p positive. If I multiply negative 3 times 800, I get negative 2,400. If I multiply negative 3 times negative 1/3, the 3's cancel. Fraction's gone. I'm left with a double negative, which is going to be a positive 1p. I don't need to write the 1 in front of the p, but I could. The next bit, a positive times a negative, is going to give me a negative. The 3's are going to cancel, and the 400 is going to remain. So I'm going to get negative 2,400 equals really 2 seconds before I trot on. Very interesting. I'm slightly concerned right now that I am doing something. Oh, I dropped a 0 here. This 4,000, I wrote 400 as opposed to 4,000. I knew I was making a mistake. I just couldn't see my mistake. I'm like, something's going wrong, because I started doing the algebra in my head and the answer wasn't making sense. So now I'm ready to get the answer that I need by adding 4,000 to both sides. So hopefully you notice I dropped that 0. When I do this, on the left side I get 1,600. On the right side I get 1p, which I can just write as p. So at a price of $1,600, the demand will be 800 units. So the answer is a $1,600 price. C is our first regression, and I think it's an exact copy of the problem that we did in an earlier section. So it says that the number of insured commercial banks in thousands are given by the table, and then it asks me to plot the data, but it tells me to use 0 for 1987. So the first point I'm going to plot is 0, 13.70. That would stand for 1987. There were 13.7 thousand commercial banks. So 13.7 thousand banks. The next point I'm going to plot for 1988, I'm going to type in 1 and then 13.12. That would say in 1988 there were 13.12 thousand commercial banks, insured commercial banks. And then the very last point, for what it's worth, 1996 minus 1987. 1996 minus 1987. The very last point I'm going to type in is going to be 9, 9.53. The 9 is going to represent the year 1996. The 9.53 is the number of banks in thousands. So I'm going to enter 10 different points. And for the first point, I'm going to make 1987 stand for 0, and then 1 for 1988, 2 for 1989, all the way up until I get to 9 for 1996. So I'm going to enter those points, make a scatter plot on my calculator, but not graph it by hand, because that's just too tedious to do. So hit my stat button, hit enter on edit, clear out the lists that are in there. For my L1, I'm going to type 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And in L2, I'm going to type 13.7, 13.12, 12.71, 12.34, 11.92, 11.46, 10.96, 10.45, 9.94, 9.53. Double check that I have all the points in properly. If I don't have them in properly, I won't get the right equation. So 0, 13.7, 1, 13.12, 2, 3, 4, 5, 6, 7, 8, 9. Have the points in perfectly. Make my scatter plot by going second, stat plot, turning the plot from on to off by hitting enter. Enter on the on, so now the on is blacked out. Hit the zoom button, arrow down or up to number 9 that says stat, and there's my stat plot. That almost looks perfectly linear. So there's my scatter plot. I didn't need to graph that on my paper, but I just needed to see that it looks linear to make sure that a line is a reasonable equation rather than maybe a parabola being a reasonable equation like in some of the problems that we did earlier in the chapter. Part B says find the equation to fit this. So I'm going to go stat, calc, and then after stat and calc go down to option 4, linear regression. I'm carrying 2 decimals. I'm going to go y equals negative 0.46x plus 13.68. I took the negative 0.458, rounded it to negative 0.46, put it in front of the x for the a. 13.68, put it in front of made it the b. And look how high the r is. The r being negative tells me that it has a negative slope. 0.99 means it's almost perfect. So this is really a good fit. Since the r is greater than 0.80, at least the absolute value is greater than 0.0, it's a really good r strong fit. Now I'm going to graph this on, and again, part D says to graph it, but don't show the graph. So I'm going to go y equals, clear the function that's in there, negative 0.46x plus 13.68. Graph it, and it looks really nice. It goes through the points almost perfectly. Almost all the points are perfectly on the line, which means this line is going to be a good predictor. Now I need to predict part E. So again, this is just on my calculator only, part D. I didn't want to make us graph this by hand because it was just too tedious. Predict the average number of banks insured in the year 2000. For the year 2000, the number I'm going to plug in, I'm going to go 2000 minus 1987. And I'm going to get 13. I need to plug into the equation. X stands for the year, Y stands for the number of banks. Into the equation, I'm going to plug in 13 for X because 13 is going to represent the year 2000. So I'm going to go negative 0.46 times 13 plus 13.68. And when I do that, so clear, negative 0.46 times 13 plus 13.68, I get 7.7 thousand banks. So the answer is going to be y equals 7.7 thousand banks, insured commercial banks in the year 2000. So that's everything that needed to be done for that long word problem, but really minimal algebra word problem. The regression problems, because our calculator is doing so much of the work, they're really not that involved. Okay, I need extra paper to do this particular problem. So I have a function for number 5 that says h of x equals 2 times x plus 1 squared plus 3. Part A says describe what's going on here. The plus 1 in the parentheses moves it left 1. This plus 3 moves it up 3. Those are the only changes that you're required to note. The plus 2 makes it skinnier. With the 2 here, we say that it stretches it vertically. It's going to make it skinnier than a parabola that doesn't have that number in front of it. So that's the describing the transformation. A negative in front of this would have reflected it over the x-axis. You would have been required to say that. The plus 1 in the parentheses makes it go left 1. The plus 3 makes it go plus 3. Now I'm going to make a table of values and sketch a graph. I'm stealing the table from my calculator ultimately. Remember when we did that table of values that I took the number in the parentheses, changed its sign. So the number in the parentheses with a positive 1, I changed that to a negative 1. And now I'm going to find that number on the x-axis. Find numbers to the right and to the left of it. So my table of values generally has 5 points. Sometimes I only plot 3 of the 5. I'm going to get all the y's from my calculator, doing a couple things. First of all, I'm going to turn the stat plot off. I'll go second in stat plot, hit enter, turn this from on to off, quit out of that. Make my window go back to a standard window by hitting the zoom button, going to option 6 that says standard. That has the window now out of that funky stat mode into a nice mode. Hit my y equals, clear out the function that's in there. Now go 2 times parentheses x plus 1 squared plus 3. This is the graph that I'm going to try to get. I'm going to now go second in table. Oh, my table's way too far away. Let me cheat. Second calc value, type in 1. Hopefully now when I go second table, it's still not there. My table's at 100. I need to get to 1. I'm going to go second window, change my table start to 1, and hit enter. Now when I go back to the table, it's not going to be at 100 anymore, and I didn't have to arrow from 100 to 1. So second window, hitting the table start to a reasonable number. Now when I go to my table, I see the numbers that I need to see. Very specifically, next to the -3, I'm going to type 11. Next to the positive 1, I'm going to write 11. Next to the 0, I'm going to write 5. Next to the -2, I'm going to write 5. Next to the -1, I'm going to write 3. My graph is going to look like that. I'm going to be lazy and only graph 3 points. The 11s really aren't that ridiculous to actually ask you to graph, but I'm only going to make my graph go up to the 5s. I'm going to plot the point 0, 5 and the point -2, 5 along with the point -1, 3 and connect my graph with a U as opposed to a V. The arrows go on like that, and that is reasonably close to what my calculator gave me. I don't have to be exactly perfect. So that would be a suitable work for part B. Now I want to do the domain and the range. Those are easy. The domain for all the parabolas was always negative to positive infinity, and there's no algebra to do. For the range, I'm going to read bottom to top. This 3, that's the bottom y for my range. And the graph goes to the top of the y-axis, which is at y equal infinity. So the top is up here at y equal infinity. So the range, square bracket on the 3 for the y because it's on the graph, round bracket for the infinity. So the range is going to be 3 to infinity. D wants the increasing and decreasing. I'm going to break the function up at the vertex. If I break the graph up at the vertex, I get 2 halves. The left half goes from the far edge of the x-axis, which is left edge is at negative infinity, to -1. And this region, as I move from left to right, the graph is going down. So I'm going to say it's decreasing in that interval. And this region, which is the region from x equal -1 to x equal infinity, as I move from left to right, the graph is going up. So I'm going to say in that interval from -1 to infinity, it's increasing. So for the increasing, decreasing answers, I'm going to say the graph is decreasing from negative infinity to -1, and it's increasing from -1 to infinity. The next two, I'm only going to get to answer one of them. The vertex is at the bottom, so the vertex is a minimum point. This graph doesn't have a maximum, so the answer to the next question state if the graph has a local maximum. It doesn't have one, so I'm not going to say that it has one. It does have a local minimum. It has a local minimum, or a local minimum occurs at the x coordinate of the vertex, which is -1, and we can say the minimum value, or the local minimum value, is the y coordinate of the vertex, and the y coordinate of the vertex was 3. And that would be a perfect way to answer question F. So it does have a local minimum because it has a low spot. The low spot occurs at the point -1, 3. When we define the local minimum, we say the local minimum occurs at an x value, and the y value is the value of the minimum. So that's everything for question 5A, I believe that was. There's a couple more of these that we have to do. Next function, number 6, gives me g of x equals 1/2 times x plus 2 squared minus 4. Again, this is number 6. The transformation that occurs, the plus 2 in the parentheses, shifts it left 2. This minus 4 moves it down 4. That's what you're responsible for. That 1/2 makes it wider, and the 1/2, we could say that it compresses vertically, which means it makes it squatty or fatter or wider. But you're not responsible to write that on the test. Just the left 2 down 4 I'd like to see. Now I'm going to make my table of values and sketch a graph. I take the number in the middle of the parentheses, change its sign. +2 is going to go to -2. I'm going to find -2 on the x-axis. Take numbers to the right of -2 and to the left of -2 to fill out my x column. Cheat and get the y's from my calculator. So I'm turning my calculator on, hitting the y equals, clearing what's in there, and then parentheses 1 divided by 2, and then parentheses x plus 2 squared minus 4. This is the graph that I'm trying to achieve. Cheat, second table, find my values. At 0, I'm at -2, and at -4, I'm also at -2. At -3, I'm at -3.5, and at -1, I'm also at -3.5, and at -2, I'm at -4. So I took all the y's from my table just to speed up the process. So now I can increment my y-axis at -1, -2, -3. I don't need to go beneath -4. I'm going to plot the point 0, -2, -4, -2, -1, -3.5, -1, -3.5, -3, -3.5, and then -2, -4. I'll label the vertex, but not the other points, being a little bit lazy here. It's okay. So this is a reasonable graph. Again, it's not maybe stellar, but it kind of looks like what my calculator gave me. It's definitely close enough. So this would be absolutely suitable for part B. Domain and range. The domain is negative to positive infinity. When I get to the range, I need the bottom y, which is -4 for the range. And the graph goes up forever to the top of the y-axis. So the last part of my range is going to be at infinity. I'm going to say the domain is negative to positive infinity. All parabolas have a range, a domain from negative to positive infinity. And for the range, I'm going to write -4 to infinity. So for part C here, my domain for all parabolas, there's no algebra, nothing, I don't even need the graph, it's negative to positive infinity. And my range is going to go from the bottom y coordinate, which is the y coordinate of the vertex, to the top of the graph, which is y equal infinity. To do the increasing and decreasing, I break the graph up at the vertex. So I got this half of the graph, which is from -infinity to -2. And this portion of the graph, which is from -2 to positive infinity, as the portion of the graphs I need to look at. This region, the region from -infinity on the x-axis to -2, As I move from left to right, the graph is going down, so I'm going to say it's decreasing in that region. And in this region, which is the region from -2 to positive infinity on the x-axis, the graph is increasing. So for the increasing and decreasing, I'm only showing x-coordinates. I'm putting infinities on the x-axis, putting the x-coordinate of the vertex, and then just trying to describe the intervals and figuring out whether they're increasing or decreasing. So for the next part, this thing is increasing. I'm just going to write INC for increasing, and it's increasing from -2 to infinity. And I'll write DEC for decreasing, and it's decreasing from -infinity to -2. So I just broke the parabola up into the halves on either side of the vertex. This vertex is a minimum point. I don't have a maximum again, so this one has no local maximum. So I'm going to write none for this. And it has a local minimum at the x-coordinate of the vertex at x equal -2, and the minimum value is the y-coordinate of the vertex. I'll say the minimum value is y equal to the y-coordinate of the vertex, which is -4. Must have one more of this style of problem, because I haven't had one with a maximum yet, and I must have to put one with a maximum. Yes, and that is number 7. Number 7 says m of x equals -3x squared plus 8. If you need to see it better, you can go -3 times x plus 0 squared plus 8 if you absolutely need to see a parentheses. The negative in front of this is going to be reflected over the x-axis. So that's something I'm responsible to in my description in part A. It's going to be turned over. If you just said it's flipped over, that would be completely fine. This plus 8 is going to move it up 8. Those are the two things that you're responsible for. The 3 is going to stretch it vertically and make it skinnier. The negative flips it over. The fact that the 3 is bigger than 1 is going to stretch it vertically and make it skinnier, as opposed to compress it vertically and make it fatter. So that's everything for part A that we need to have. Because there isn't a parentheses, the number that I stuff in the middle of my x column is going to be 0. And the numbers to fill out the columns, the x column, are to the left and right of 0, which are 1 and 2, -1 and -2. I'm going to graph the function on my calculator so I can steal the table. So I'm going to go y equals clear -3x squared plus 8. That's the graph that I'm shooting for. Second table, there we go. There's -2, -4, and 2, -4. So part of the points I have are -2, -4, and +2, -4. I need +1 and 5, -1 and 5. And the vertex is at 0, 8. Again, my tables will always pair out this way, where the top y's and the bottom y's are the same, the vertex is in the middle. And now I need to sketch a graph. I need to get up to 8, so I leave myself room. 1, 2, 3, 4, 5, 6, 7, 8. I'm plotting the point 2, -4. So this is 2, -4, -2, -4. -1, 5, and 1, 5, and then 0, 8, which is the vertex. I need to probably label the vertex, but maybe not as much the other points. So this, again, if I look at this graph, and I look at my calculator's graph, they're close enough that, and my graphs don't need to be any more accurate than that. So there's my table of values in my graph. For this one, the graph goes all the way down to the bottom of the x-axis. So the range, when I go from bottom to top, I'm going to go from the bottom y, which is at -infinity, to the top y, which is at 8 for my range. My range is going to be from -infinity to 8, the bottom y's to the top y's. My domain is still negative to positive infinity. There's still no algebra or no picture that I need for the domain. So to do part C, the domain is negative to positive infinity. All parabolas have that for their domain. Because this is flipped over, the range looks a little bit different. It's negative infinity to positive 8. If I split the graph at the vertex, I get this region that goes from x equal to negative infinity to x equal to 0. And I get this region from x equals 0 to x equals infinity. So this would represent the region negative infinity to 0 in terms of x. This would represent the region from 0 to infinity in terms of x. This region, as I move from left to right, the graph is going up. So that's the increasing portion of the graph. This region, as I move from left to right, the graph is going down. So that's the decreasing portion of the graph. So when I go to answer the increasing, decreasing question, I'm going to say it's increasing from negative infinity to 0. It's decreasing from 0 to infinity. Always the increasing and decreasing on parabolas, I just split the graph over the vertex, and that will help me see the parts that I need to see. So this one I'm going to say it's increasing in the region negative infinity to 0. Increasing and decreasing usually only get round brackets because the 0 in this case is a turning point and it's not increasing or decreasing, whereas the range in the domain, if there's a point that's actually on the graph, it usually gets a solid square bracket like I did for the 8. This graph, the 0, 8's a maximum, not a minimum. So I'm going to answer the part that asks about the maximum. A maximum occurs, it has a local maximum. At x equal to 0, that's the x coordinate of the vertex. And the maximum value is going to be the y-coordinate of the vertex. I'm going to say it's y equal to 8. And I just plucked out that answer to that question by taking both components of the vertex, separating the x and the y. This vertex is a maximum point. It's not a minimum point. The graph doesn't have a minimum point. So in terms of a local minimum, I'm going to just say there isn't any because the parabola has a top but not a bottom. So that's the end of that problem. That was actually number 7, I guess. Not many more problems left to go. Problem 8 wants me to use completing the square to write this in standard form, sketch a graph, label the vertex, steal the graph from my calculator, which means I might have to tweak the window a little bit. So to do this problem 8, part A, the first thing I'm going to do is group the x's. I'm going to go x squared minus 4x. Dump the plus 5 out. Now I'm going to find the c. c is half of negative 4 squared. Half of negative 4 is negative 2. Negative 2 squared is 4. I'm going to simultaneously add and subtract 4. So I'm going to get m of x equals x squared minus 4x plus 4. And I'm going to go plus 5 minus 4. Because I added 4 without a number in front of the parentheses. I need to subtract 4. I'm going to factor the parentheses, and that's going to factor into x minus 2 times x minus 2. I'm going to combine those to a 1, and the standard form here is going to be m of x equals x minus 2 squared plus 1. The vertex, when I go to sketch my graph, I change the sign of the number inside the parentheses. That's going to be the x-coordinate of my vertex. I keep the number outside the parentheses. That's the y-coordinate of my vertex. The vertex is going to be at 2, 1. So when I go to sketch my graph, the window that I have is going to be adequate. So when I go to sketch my graph, that's the part B, I need to label the vertex at the point 2, 1. And I'm going to sketch a graph. And again, to make sure I haven't messed up, I'm going to graph both functions, the original function and the function I came up with. I'm going to do y equals, the original function is x squared minus 4x plus 5. My new function is parentheses x minus 2 squared plus 1. When I hit graph, if I only see one function, then I've done well. If I've seen two functions and the graphs aren't the same, I've made a mistake. So I hit my graph button. It draws the first function. It draws the second function. So the graphs are the same. I make sure the vertex is right by going second calc value, typing enter on 2, and it tells me the y is 1. I've done perfect here. I rewrote the equation so I could picked off the vertex, sketched a graph, copying the graph from my calculator. It looks something like that. Again, I'm not asking for that accurate of a graph. That's more than accurate enough for borrowing the graph from my calculator. Nine, same deal, a little bit harder. The little bit harder is because the 4 in front of the x squared. Same question, so I'm going to group the x's, make this negative 4x squared plus 16x, move the minus 6 out, factor out the negative 4 from the x's, and get x squared minus 4x. Find the c. C is half of negative 4 squared, which is 4. So I get negative 4 times x squared minus 4x plus 4. If I cleared this parentheses, not that I have to, but if I cleared this parentheses, I'd get negative 4x squared plus 16x, and then negative 4 times 4 is minus 16. So what I've actually done to the original problem is minus 16. So next to the minus 6, I need to add 6. So for the, I'm going to go add 16, should I say. Because what I've actually done is minus 16 in the parentheses. If I distributed the negative 4 through, I need to add 16. Now I'm going to factor. I'm going to get h of x as negative 4. This factors into x minus 2 times x minus 2. The negative 6 plus 16 is positive 10. So my function, written in standard form, is going to be negative 4 times x minus 2 squared plus 10. When I go to graph it, it's going to be a parabola. The vertex, I change that sign in the parentheses, keep the sign after the parentheses. The vertex is going to be at 210. When I go to graph, when I set my window up for this, because the x coordinate of the vertex is at 2, the negative 10 to 10 window is going to be fine. But the y coordinate of the vertex being at 10, I should probably bump the y max up so I can see that 10 better. I'm going to change my y max to 15. And I'm going to graph both functions to make sure I haven't messed up. So I'm going to hit my y equals button, clear and clear, type the negative 4x squared plus 16x minus 6 along with negative 4 times x minus 2 squared plus 10. Change my window so that the y max was 15. So I have my windows set at negative 10 to 10, negative 10 to 15. In my equation, my y1 is the initial equation. My y2 is my answer to part A. When I hit graph, I hope to only see one line. If I see two parabolas, I've messed up. I don't. That's good. Now I check my vertex by going second calc, typing enter on value, type the x coordinate of the vertex, which is 2, and it plots the vertex for me, so I did that perfectly. I rewrote the problem so I could know what the vertex is. The original graph, the graph of the original equation, the graph of my equation have the same graph, so I did perfect. Oh, I need to copy the graph then. So the graph, I need to have the point 210 labeled as the vertex, and the graph looks like it goes something like that. So that would be adequate enough for the graph for part B of 9B, for what that's worth. So I think just 3 more problems, 10, 11, and 12. 10's going to require a bit of algebra. 10, again, gives me a, 10 and 11 are about the same problem. In fact, exactly the same problem, just different words. And they involve a ball being thrown straight up in the air. This problem, the 6, means maybe the ball initially was 6 feet in the air and then it gets thrown up and it comes back down. Let me graph this function just to show you the flight of the ball. I'm going to make an x min of 0 because before 0 seconds, we don't know, the function doesn't make sense. I can't imagine a ball flies for much more than 10 seconds. I'm going to make my x max 10 because the x's are the time in seconds. The y min, that's the height in feet. The ball can't go underground, so its minimum height is 0 feet. And for the y max, I can't imagine throwing a ball much more than 200 feet in the air. So I'm going to graph this function just so you can see the flight of the ball. But at my y equals, clear out the stuff that's in there, go negative 16x squared plus 80x plus 6. Hit my window, 0 to 10 on the x's, 0 to 200 on the y's. I imagine that 200 is overkill. I hit graph, and I see the flight of the ball. Again, if I want to answer the part A, how long does it take to hit the ground? It hits the ground right there. It looks like that's at 1, 2, 3, 4. It looks like exactly 5 seconds. I'm not sure if that is or isn't exactly 5 seconds because the graph actually looks like it's a little bit right at the tick mark. I think it's a little more than 5 seconds. To find out where the ball hits the ground or how long it takes the ball to hit the ground, I set the function equal to 0. I want the height to be 0. I'm going to solve for t. I'm going to get 2 answers. I want the answer that's positive. I can divide through by 2 to make this easier. I'm going to make this 0 equal to negative 8t squared plus 40t plus 3. I can't factor that. I'm going to use the quadratic formula. I'm going to make a equal to negative 8, b equal to 40, c equal to 3. I'm going to go t equal to negative b, which is negative 40, plus or minus the square root of b squared, which is 40 squared, minus 4ac, which is 4 times negative 8, times 3, all over 2a, which is 2 times 3. And this is going to give me t equals to negative 40 plus or minus, and then under the square root, I get 40 squared minus 4 times negative 8 times 3. Under the square root, I get 1696. Second square root, 1696, which is 41.18. So I get negative 40 plus or minus the square root of 1696, which is negative 40 plus or minus 41.18. Really? Over 6. I'm worried about this. I'm going to recalibrate to make sure I haven't messed up. 16 divided by 2 is 8. 80 divided by 2 is 40. 6 divided by 2 is 3. Negative 40 plus or minus 40 squared minus 4 times 8 times 3. Graph. Second calc. Value 5. Yeah. Seems reasonable. I'm thinking I made a mistake somewhere here. Let me see if I can find it real quickly before I say something. No, I've made a mistake. I'm going to give myself room, and I'm going to redo the quadratic formula. I'm not happy with this because I wasn't getting an answer around 5. I don't know where my mistake is. I don't see my mistake. Crossing it out, starting over. I'm not going to do this dividing because I'm worried I made a mistake dividing. So I'm going to use a equal to negative 16, b equal to 80, c equal to 6, and go t equals to negative b, which is negative 80, plus or minus the square root of 80 squared minus 4 times negative 16 times 6, all over 2a, which is 2 times negative 16. This is going to give me t equals negative 80 plus or minus the square root of, and under the square root I get 80 squared minus 4 times negative 16 times 6. That should give me 6784 over negative 32. Now I'll do the square root of 6784, which is 82. Ooh, I'm equivalently unhappy with myself, but I guess for the wrong reason. I don't think I actually was making a mistake last time. I just think I was tired and I didn't realize I was doing nothing wrong. And I try to do math in my head, which is sometimes dangerous for me to do. So this is what I get when I use the quadratic formula. I need to make two problems up. I'm hoping for an answer around 5. One of the problems is going to be negative 80 minus 82.37 over negative 32. The other is going to be t equals to minus 80 plus 82.37 over negative 32. I'm going to do both of these on my calculator. So the first one I'm going parentheses negative 80 minus 82.37 divided by negative 32 and getting 5.07 seconds. That seems reasonable. And then for the other one, I'm going negative 80 minus 82.37 divided by negative 32. Oh, I needed a plus there. Second enter, change the minus to a plus. So I get negative 80 plus 82.37 over 32, and this gives me negative 0.07, which is before the ball was thrown, so that time doesn't make sense. This is going to be the answer that I'm searching for. So at 5.07 seconds, the ball's going to hit the ground. So the answer to part A is at 5.07 seconds. I actually don't think I had a mistake here. I was just trying to do some math in my head, and I did it wrong in my head. So this was actually probably okay. Would have got the same answer had I stuck with that. When does the ball reach the maximum height? It reaches the maximum height at the x-coordinate of the vertex. So I'm going to find the x-coordinate of the vertex. That's the time where it reaches the maximum height. I do that by using the negative b over 2a formula, where b is 80, so I'm going to get negative 80 over 2a is going to be 2 times negative 16. So this is going to be negative 80 over negative 32, which doesn't come out to a very nice number. I get negative 80 divided by negative 32. I get 2.5. So it takes 2.5 seconds to get to its maximum height. To find out what its maximum height is, I'm going to plug in 2.5 in for t. I'm going to go negative 16 times 2.5 squared plus 80 times 2.5 plus 6. Cheat and use my calculator. Negative 16 times parentheses 2.5 squared plus 80 times 2.5 plus 6 equals, it's 106 feet. So the answer to this question, or the answer to the last two parts, is it takes 2.5 seconds to reach its maximum height. Its maximum height is 106 feet. Check all of these answers on my calculator real quickly. I'll show you how to do that. Hit my graph function. If I type in 5.07, if I hit second calc value 5.07, the y that I get should be very close to 0. So this says at 5.07 seconds, it's 0.32 feet above the ground. That's just a few inches. The reason this isn't exactly 0 is because my answer is rounded. I'd like the y to be exactly 0, but 0.32 feet is close enough to 0 for me to be happy. If I do now second calc value and type in 2.5, it shows me that the vertex is 2.5, 106, which means at 2.5 seconds it's at its highest height of 106 feet. So I've double checked to make sure that at 5.07 seconds the ball is basically on the ground and that its maximum height occurred at 2.5 seconds of 106 feet, which that vertex shows. 11 is essentially the same question. New function, but same sort of strategy. Again, 11 gives me the same sort of thing, but one new question. When will the object have a height of 85 feet? So I have a question that measures the height of an object. I want to know when the height's 85 feet. Let me graph this and show you real quickly. So if I graph this, I get negative 16x squared plus 96x plus 5. Graph it. This shows the height of the ball. I want to know when the height's 85 feet. And I'll be able to show it to you graphically, but I don't know the answer yet. So I'm going to get the answer, then show you how it shows on the graph. For part A, I'm going to make the height 85 feet and solve for time. To do this, I need to solve by either factoring or the quadratic formula. Both require the problem to be set equal to 0. If I set this equal to 0, I get negative 16t squared plus 96t plus minus 80 by minusing 85 from that side. Dividing everything by minus 16. It's going to leave me with 0 equals to positive t squared minus 6t plus 5. Now that I have it set up nicely with small numbers, I can factor. This is going to give me 0 equals to t minus 1 times t minus 5. I'll set the t minus 1 equal to 0 and get t equal to 1. I'll set the t minus 5 equal to 0 and get t equal to 5. So this says at 1 and 5 seconds, the ball is going to have a height of 85 feet. Which means if I go to my graph, I do second calc value, type in 1, it's going to show me at 1 second, it's 85 feet in the air. If I do the same thing, do second calc value and type in 5, it also shows me at 5 seconds it's at 85 feet. So it starts at 5 feet up, at 1 second it's at 85 feet, and then it goes up to its top, and then again at 5 seconds it's back again at 85 feet. How long will it take the object to hit the ground? It's at, looks like 1, 2, 3, 4, 5. It looks like 6 seconds. It might be a little more, it might be a little less than 6 seconds. And to do that, I set the function equal to 0. I'm going to go 0 equal to negative 16t squared plus 96t plus 5. I can't factor that. I'm going to use the quadratic formula. I'm going to get t equals to negative b, which is negative 96, plus or minus the square root of b squared, which is 96 squared, minus 4ac, which is 4 times minus 16 times 5, all over 2a, which is 2 times minus 16. Break out a new sheet of paper to do this because I don't want to scrunch my work. When I do this, under the radical, I get 96 squared minus 4 times negative 16 times 5, which is 95/36. So I get t equals to negative 96 plus or minus the square root of 95/36 over negative 32. I'm going to do the square root of 95/36, evaluate it to 2 decimals. I get 97.65. So I get t equals to negative 96 plus or minus 97.65 over 32, negative 32. Make the separate problems, one with the plus, one with the minus. One is going to be negative 96 plus 97.65 over negative 32. The other is going to be negative 96 minus 97.65 over negative 32. Those are the times where the object would be hit beyond the ground level. The first one, I do parentheses, negative 96 plus 97.65 divided by negative 32. And I get at negative 0.05 seconds. This is before the ball was actually launched. Because the ball had an initial height of 5 feet, this answer doesn't make sense. The second answer is going to be what I need, the negative 96 minus 97.65 divided by negative 32. And I get 6.05 seconds. So just over 6 seconds. When I look at the graph touches the x-axis just past the 6 tick mark, and the answer to part B is going to be at 6.05 seconds. I'll write SEC for seconds because I didn't leave myself enough room. Part C, determine the maximum height. The maximum height is the y-coordinate of the vertex. So I need to get the x-coordinate of the vertex and then the y-coordinate of the vertex. The x-coordinate of the vertex is the time that it gets the maximum height, which I get by going negative b over 2a. b is 96, so this is going to be negative 96 over 2 times negative 16. This is going to be negative 96 over negative 32. That's 3. That says at 3 seconds the ball reaches its maximum height. And when I plug 3 in, go negative 16 times 3 squared plus 96 times 3 plus 5, I'll actually get the maximum height. So if I do this, negative 16 times 3 squared plus 96 times 3 plus 5, I get 149 feet. So it says at 3 seconds the ball gets its maximum height of 149 feet. Because this is only asking for the maximum height, I'm only giving the 149. I could show it on the graph by hitting the graph button and doing second calc value, typing 3, and that shows me at 3 seconds the ball's at its maximum height, or the object, of 149 feet. All right, one more problem, and it's a nice regression problem, so there's no algebra to do for it. It's just punching buttons on my calculator for the most part. But it might actually ask me to find a vertex. So 12 gives the flight of a baseball from a bat at some times. And the first thing I'm going to do is make a scatter plot of the data, leave the data just how it fits. It goes stat, edit, clear out the lists that are there, make my new data, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. The height of the ball is 5 feet, 20 feet, 60 feet, 25 feet, and 5 feet. I'm going to make a scatter plot, so I'm going to go second, stat plot, hit enter, turn my plot on. Then hit my zoom button, go to option 9, and I don't like that 60 so much, but I'm living with it. Doesn't look as nicely like a parabola as I'd like it to look because this data point there is whacked. Let me change this to a 40 and recalibrate my data so my function's going to work better. And I'll change it on your handout shortly. So I'm changing that to 40. And now when I do second stat plot, I get so much nicer of a graph. It looks so much more like an absolute value, but it's definitely parabola-ish. Let me clear the function that's in there. Clear this function. So that looks so much nicer than what I had. So there's the scatter plot. I'm going to find a linear and a quadratic function, a line and a parabola. I'm going to graph both of them to show you that the parabola is better. First thing for the linear, I go stat, calc, go down to linear regression, hit enter twice, and I get, look, the R is horrible at 0.05. The equation, it says it's 0.5x plus 17.5. That's the linear regression equation. If I graph that at 0.5x plus 17.5, that equation is cruddy. It's not going to predict the flight of the ball at all. But if I go stat, calc, and go to quadratic regression and write negative 7.5x squared plus 45.5x minus 35, that's just taking the values of a, b, and c, plug them into the formula. If I graph that equation by going y equals clear negative 7.5x squared plus 45.5x minus 35. When I graph that, it's going to go much closer to the points, and so it's a good predictor. So the quadratic is definitely the better fit. So answering this question, the equation that maps the data better is the quadratic. You can just tell by looking that it's a better predictor. Part D says to do the graph on your calculator. Don't make a copy. So there's my graph on my calculator. E wants me to predict the maximum height. The maximum height is the y-coordinate of the vertex, which means I need to be able to find the vertex to get the maximum height. The x-coordinate of the vertex is the time that it gets the maximum height. The y-coordinate is the maximum height. So I'm going to get the x-coordinate of the vertex by using the negative b over 2a formula. The b is 45.5. The a is negative 7.5. So I'm going to get negative 45.5 over 2 times negative 7.5, which is 2 over negative, that comes to negative 15. So I'm going to get negative 45.5 divided by negative 15. And I get 3.03 for the x-coordinate of the vertex. So you can see that. And then for the y-coordinate of the vertex, I'm going to go negative 7.5 times 3.03 squared plus 45.5 times 3.03 minus 35. And that's going to give me my prediction, which isn't going to be perfect because I can tell the function itself doesn't go as high as the baseball goes, but it is what it is. When I'm using an equation to make predictions, that's an estimate. It's just an estimate. It's not guaranteed to be exact. So now I'm going to type in negative 7.5 times 3.03 squared plus 45.5 times 3.03 minus 35, and that gives me 34.008. Let me make sure that actually shows up on my graph. Put my graph back on, second calc, value 3.03. That is the vertex. So this actually says the ball is only going to go about 34 feet high. So the maximum height is about 34 feet. That's what the equation predicts. I know the ball went to 40 feet because I said it went to 40 feet. But because I'm testing on the regression, I want you to use the regression. And so this shows the flaw of using regression in that you can make predictions and your predictions defy reality. But it is just an estimate, and it's a strategy that mathematicians use to make estimates, our predictions. So it's an important skill to have. Okay, so that's everything on the review, done ultra fast. Hopefully you're able to keep up with my pace. If not, hopefully you paused and rewound as you needed to. If not, and you're feeling not ready for the test, come visit me and I'll try to help you out and get you ready for the test.